All right. Thanks, Mitch. So as mentioned, we're going to give you a brief little demonstration of our brachytherapy module. So this is the home screen for those of you who have seen it in the past. The home screen of our Bolus software gives you the option to select whichever module that you might be wishing to use. So we're going to go ahead and select our brachytherapy module, and that our workflow process whereby we want to load in our DICOM information. So as Mitch mentioned briefly in the present, we take in DICOM info from the treatment plan briefly in the present. So that brings in the CT scan as well as the structure that we're going to use to create an applicator. In this data set applicator here, you can see we have a couple different viewing panes. We have the axial view in the top left, the coronal view in the bottom left, and the middle view in the bottom right, as well as a 3D rendering, as well as of your selected objects. Now I have two objects that we can use to create a brachytherapy applicator with tonight. I'll run you through both of these real quickly. The first is the one that Mitch showed you in the presentation. It's a nose applicator. So from here, what we want is a custom designed patient specific that's going to fit their unique anatomy. So if I zoom in here, this is just a simple water phantom of a head. So you can see it's been outlined with wires where we wanted to ensure that the bolus would cover. We extended it by roughly 2 centimeters in each direction. But the idea is to create an applicator that would completely cover any time that we wanted to treat. So from here, we select from the drop-down menu our structure that we want to use to create a bolus or create an applicator. So I'll select the nose, and that prompts our software to open up some modification features and some editable windows that we can use to make the best applicator for the patient. So you can see the default is to bring in catheter trajectories running left to right. I can move these around a little on where I might want them. Within our software, we also have abilities of varying the distance between them. So this inter-trajectory distance that you see on the right-hand side here defaults to 10 millimeters. Simply means that you're going to have 10 millimeters in between themselves. But I can decrease that if I wish, if I want to have them closer together, or I can split more if I wanted to have them maybe 12 millimeters apart as opposed to 10. That's really the user and how you want to treat within your particular clinic. Where this was designed, we wanted to create them with the 10 millimeters here, the 10 millimeter space in between them. Another thing that I can adjust is the number of their trajectories, so I can decrease or I can increase that. You can see here even there's a CT or an indent of where the CT wire was positioned on the patient. So that'll kind of give of what we want to cover with our trajectory, with our brachy tunnels. I guess we want to ensure that with our that indented makeshift tumor completely covered. You can tell that there's a bit of space on the bottom right now that doesn't have a green trajectory line, but have a green trajectory. That's done on purpose, just to an additional feature that we have for any text that I'll show you here in a moment. From here, if I want them to run left to right, you see on your screen there, I can do that. Or we can set this set the plane menu to a given orientation. It's referring to this plane that I highlight yellow, and I move my mouse cursor over it. It's referring, and that just dictates the orientation trajectory. So if I select something to create sagittal, it will allow them to in the superior direction. Coronal is certain areas of the body, but not particularly for this one. So I'm really choosing between the sagittal and the axial viewing plane. Just for this demonstration, I'm going to show the plane itself. Another editable feature that we have is that the trajectories are going to be from the patient surface itself. Again, that's default 5, but that can be adjusted based on the user's description there. Down a little, and finally we have the tunnel radius, which dictates the size of the holes. So I can change that to 2 millimeters if I want, 2.5, whatever. We'll put it at now. So once we're happy with where our set, what we can do is simply click generate trajectory. What it does is embeds those settings for applicator itself. So now you can see that all of these lines that were originally on the surface are now illuminated the 5 millimeters from the patient itself. Now what I can do after I've generated those trajectories, I say, okay, well I need another one down here, and in order to ensure complete coverage of this. So that we have an option over here that says add more trajectories. So I can select that option, and it generates another one that I can simply move into place. And click generate again, and now we have an additional line that's been added. An additional, I can add a couple, need them. But we have the ability, the user could look at this structure. And within their own experience, how many trajectories they may need. They know if they're going to have to add more, if they're going to, maybe want a little bit of less spacing or whatnot, they can add more trajectories in between, maybe one between. And we also provide editing features. So if you want to click on any one of these particular trajectory lines, it will show you a series of nodes. And what these red nodes allow you to do, you can locally change the shape of these trajectory lines. So get you a good example somewhere here where there's a little bit of a bump there. If I want to smoothen that out a bit, so that I can simply locally smooth out this trajectory line a little bit in order to ensure that it's not following too steep of a curvature. Anything on this the bolus right now would be fine for the iridium source. But if you see a little bump caused by something on object file, like a bump from T-wire, you can manually go in and smoothen that out. Or what you could do is, if you know that the area along the nose, you want your trajectory line to be a little bit farther away. You can shift the entire line either closer to the patient or further away from the patient. But just do it one at a time so that you don't have to adjust every trajectory lines. What you can do is to just move one at a time. Once you're happy wherever they are, as Mitch mentioned, it's a simple click and forget. I hit subtract, and our algorithm goes through. It's going to look at where those trajectories are, perform a subtraction operation, and then in a matter of seconds, what I'm left with is an object that you see here that has these tunneled right into the object itself. And I can set this up on my 3D printer. So what else our software point of view is go back to post-processing, and what that does is it opens on top of the other views that you saw originally. So what we can do here is the patient's ID tag, it's the orientation. So this was simply called, move it in the right place there. This one was simply called, head scan 1. Just place it down anywhere. And that's going to add the ID tag of the patient's name directly onto the structure itself. And that would be printed right there, so that you never have a patient being treated with a bolus that doesn't quite belong to them. We also provide a cropping plane. Demonstrate that very quickly. The cropping plane is used to crop the bottom of it itself, so that you're getting that nice flat surface that's going to come in contact with your print bed, and you don't have to worry wobbling very much. You know that's going to have a nice sharp edges with a nice flat edge that's going to sit on your print bed. And then from here, it's just a simple export, and this file can be set up to print in a matter of minutes, and you can carry on with your day, and have this printing in the background. Now, another thing that I'd like to show is Scalp case, because that is slightly different on how default we could fit with catheter trajectories. So default, where in the nose case we need to choose the axial or the views. This one's curved in 2 dimensions, so the a 90-degree or an orthogonal cropping plane doesn't quite work for this one. We can see the outline of the tumor volume that we wanted to treat. We wanted to treat a large simulated case on the scalp. So what we can do is, instead of one of these options that doesn't quite fit the applicator fully with the trajectory, rotate the cropping plane by these arrows in the top right-hand corner. So I can rotate that a couple degrees. I think that was 50 degrees there. And what I can simply do is add more trajectories on the side. And then you can see that now by rotating that cropping plane, we've now covered the extent of this PTV, or of this treatment volume that's indicated by the indent from the CT wire. And we can, again, generate those trajectories, perform any modifications that you saw, similar to the nose applicator. We can manually move some of these around if we wish. And finally, extract. And based on these user-defined settings, what's going to happen is now this object is going to have C tunnels built in, just like it did with the nose applicator. However, the plane that generates tunnels is not 90 degrees, not to your axial sagittal. It's a little bit off angle, and you can see that there's still. And again, more trajectory. Again, this would print just like that. You might have to introduce materials, but this would print. We have one printed at our office right now, and at our office it came out looking great. And you pop it off, fit it with your afterloading catheters, and then you can be set up with catheters.